Hi, I'm third class Hamlet.
And I'm third class Troch, and we're presenting the sheer strength of chalk. Our objective was to determine the sheer strength of chalk. To do this, we developed a device that with 2 boards stacked on top of each other and 3 holes drilled in the boards. We then made up a little device that held the boards steady. We inserted 3 pieces of chalk into the boards, and we pulled on the top board to see how much force it would take to break the chalk. We then recorded that amount of force, and we used it to calculate the shear flow and then to calculate the shear strength of chalk. This is our device. The 2 boards are inside this little metal bracket, and there's 3 holes drilled back along for the chalk. And this is a spring scale, and we use that to record the force that it took to break the chalk. And this is a video of what it looks like when we perform the experiment.
In that video you saw a force being applied by me to a spring scale that was attached to the top board, which was allowed to move, and the bottom was fixed. So that created a shear force along the chalk. And then that force, after 6 trials, we found the average to be 43.2 pounds. We set that equal to shear flow by dividing it by the spacing between the 2 pieces of chalk, which was about 3 inches, which gave us a shear flow value of 14.4 pounds per inch. And then shear flow is also equal to the shear force times the first moment of area divided by first moment of inertia, or VQ over I. And from that, we were able to solve for V, or the shear strength of chalk, which turned out to be 86.4 pounds. And it seemed really high, which is because of 2 main problems with our experiment. The first was in the device itself. There was a lot of friction between the 2 2x4s that were fastened by the chalk, and also between the boards and the device itself. We tried to use chalk dust to minimize that, but the friction still created a lot of resistance. The second problem was that the holes weren't completely lined up such that the force was applied to the 2 pieces of chalk at the same time. They were slightly offset, so when the shear force was applied, it was only really being applied to 1 piece of chalk, and then when that one gave, it applied it to the second one. So our shear force value is a little bit off. And we know this because when a point load was applied to a piece of chalk by hanging a string over a piece of chalk, we held down one end and pulled down on a spring force scale attached to the string. We only got about 28.7 pounds to cause it to fail. That's it. Thank you very much.